let us get going with today's session. So today we're going to be talking about trigonometry, and in terms of exam questions, trigonometry is in paper 2, and in terms of this part of trig, there are 5 main types of questions that we have to deal with, which we will deal with over the next 2 lessons. The one is trig expressions, so how to make them sort of calculate the value without using a calculator. So that would be kind of type 1. Then there's the express trig. In fact, let me get a highlighter. So this is find the value of trig expressions without a calculator. So that's one type of question. Then express trig ratios in terms of a given variable. So that's another type of question. Simplify a trig expression. So that's another type of question. And then prove an identity. So that would be another type. And then solve a trig equation would be another type. So these are the 5 types of questions I will try to touch on over the next 2 lessons. Give me a thumbs up if that sounds about right to you. You've heard of these types of questions before. Thumbs up if that makes broad sense to you. Thumbs down if some of that stuff sounds completely new to you. Okay, so this is the sort of place we're going to play in. Now, in order to do trigonometry, there's a couple of bits of information that we need to know. Some basic information that we need to bring to the question. And so I just want to have a quick little recap of some of that information. So the first bit of information is often what we call SOHCAHTOA, and it's basically just the definition of trigonometry. So SOHCAHTOA. And what SOHCAHTOA does is it gives us the definitions of the trig ratios. And when we deal with trig, we always have what's called a reference angle. And then we have the sides, or the ratios that come from the sides. Now, what can also happen is that trigonometry can happen on the Cartesian plane. And when it happens on the Cartesian plane, instead of using like O, A, and H, instead what we use is we use Y, X, and R. And so that's why sometimes you see the trig ratios in terms of X, Y, and R. It's just when the right-angled triangle is being drawn on the Cartesian plane. And so we need to know how to work with triangles on the Cartesian plane. Give me a thumbs up if that broadly makes sense, or if there's a question about that content, let me know now. Does anybody want to clarify anything about that idea? Okay. Then something else we need to be aware of is something called special triangles. And what do we normally use special triangles to help us with? What type of question would a special triangle normally be involved in? I'd love someone to put their hand up and help me. Like, where do we normally use special triangles, and what type of question? Anybody got an idea? Okay, who?
From Tandolwetu.
Tandolwetu, what do you normally use special triangles for?
So good afternoon, sir.
Hey, how's it going?
About that. Quite well, I guess.
Cool.
But I think that we use special angles when we're dealing with questions such as calculate the value of a trig expression without using a calculator. Is that correct?
You are perfect. Yes, that's exactly. Let's go back. So it's the question type 1, right? It's when you don't have a calculator, when you're not allowed to use a calculator, and you have to show how you evaluated this. Then we use these things called special triangles, which are like 30, 60, 45, and then when it falls exactly on the like a 90, 180, 270. Okay, so we're going to see that come up later. So that's something we need to know. Then we also talk about something called the reduction formula. So the reduction formula is often thought about in terms of the cast diagram. And what it allows us to do is it allows us to take angles that are bigger than 90 and reduce them to acute angles. So say, for example, I said to you, what is the value of the sine of 150? Well, the sine of 150 in terms of this diagram would end up with a triangle in quadrant number 2. Okay, so the 150 would be here. And using this diagram, we can work out an acute value where the angle is smaller than 90 that is equivalent to the sine of 150. So I want to ask you right now in the chat, what is, if I reduce the sine of 150, what am I going to get? Does anybody know what the sine of 150 is going to be if I reduce it? I'd love to see in the chat, or if somebody'd like to raise their hand, what is the sine of 150 the same as? Using what's called the reduction formula.
Tandoleti has an idea.
Okay, Tandoleti, let's go to you. What do you think?
So I'm not sure if I'm 100% correct, but I think we could say sine of 180 minus 150 because the angle 150 is less than 180, and then we can get sine 30. Is that correct?
Sine of 150 is in the second quadrant where it's can you guys hear me now? I think I lost some of you for a second there.
Yes.
Yes, Mr. There was a bit of a lag there.
Okay, apologies everyone. So I can see Nolwazi's put it in the chat, and I think Tandawetu would have said this, is the sine of 150, it's in quadrant number 2, so it's positive, and it's 30 degrees away from the nearest horizontal. And so you see that the sine of 150 is the same as the sine of 30, or positive the sine of 30. And what that is called is a reduction formula, where we reduce a trig ratio using the nearest horizontal and the cast diagram. So all angles that are in quadrant 2 have this form 180 minus theta. So in this case, it was just 180 minus 150 to get the 30 degrees that I'm talking about here. Okay, so that is a brief review of the reduction formula. And then the other thing in the section that we need to think about is something called identities. Now, we haven't started the questions yet. I'm still doing a bit of a recap, but I just think it's a good idea to go back over these things. In trig, the two main identities that we need to be aware of are that the tan of theta is the same as the sine of theta over the cos of theta. So that one. And then the other famous one is that sine squared theta plus cos squared theta equals 1. You can rearrange that to get these two, but really the highlights of the identities are these two ones over here. Just give me a thumbs up if you recognize those trig identities, thumbs down, and please do vote either way if you don't recognize those trig identities. Okay. All right. So as we begin today's lesson, these are, if you need to recap some of these skills, I would definitely, do that, but these are going to be popping up in the questions as we go. And so let's get started with some actual questions, and I hope that that little bit of a recap helped you get going. Okay, let us start with this question over here. So it says here that triangle MNP is a right angled triangle. Write down the trig ratio for. Now, I'm just going to choose one option to start with. I want you to tell me what is the sine of alpha if I'm looking at this diagram over here. So take a moment, look at that, and pop in the chat, what is the sine of alpha mean in terms of this diagram? Owami, I see your hand is up. What do you think, Owami?
So I think since sine is opposite over hypotenuse, right?
Yes.
The sine of A is gonna be mn over mp.
Mn over mp. I completely agree with you. The sine of alpha is just going to be, so what's opposite the alpha? It's the mn. And what is, so sine is over h, so the h is going to be the mp. Perfect. I like what I'm seeing, and I like in the chat what I'm seeing. Things are looking very good. Now, for your second question, I want to ask you, what is the sine of beta? I want you to pop that in the chat. Nicely done, Owami. So we've done A. What is B going to be? So something changed and something stayed the same. I'm wondering if anybody feels like explaining to us what changed. Well, Mike, you know what's going on. I can see. So Nobuseto, Owami, the opposite. Okay, so if we're focusing now on beta, then the side that is opposite the beta is the NP. So that would be NP over, and the H is still going to be MP. So the H is going to be the, so we're going to get that over that. Okay, so that's a basic application of trigonometry. I want to see in the vote in the meeting chat, thumbs up if you felt okay with that, thumbs down if you felt a bit lost. Okay, so we're gonna okay, take it up a notch. Now we are going to put some values into play. So in the next part of the question, it says MP is 13 and NP is 5. Find me the cos of beta. So what is that going to be? And I want to ask what, because this is a little bit harder, so I'll give you some time. We need to find the cos of beta, and we might have some problems along the way. Maybe somebody can help me identify the problem. Take a moment to look and read it. I'm trying to find what the cos of beta is, and I want to know what problems I'm hitting.
Mr. S, we have a hand from Owami.
Okay, Owami, what do you think? What problem have you hit?
So I think since the opposite is mn over mp,
Yes.
we're gonna have to solve for mp using Pythagoras. So.
Yeah, okay, that's exactly what I was looking for. So it's this missing side. So we need to use the theorem of Pythagoras to help us. So let's go ahead and do that. What is the value of mn going to be? So using Pythagoras, put your Pythag, my reason. Mn should be 12. Okay, so now I want to know from you, what is the cos? If I tell you that Mn is 12 and I use the theorem of Pythagoras, and I just want to point that out, that's really important. When you have two sides in a right angled triangle, you can work out the third side using Pythagoras. Nicely done, Tondo Wetu.
Mr. S,
Yeah,
can you take a question from Katlaho?
I can. Kakleko, where you can unmute Kakleko and we can go from there.
Good evening, sir.
Hey, how's it going?
Yeah, okay, sir. So I just wanted to ask if does writing SOHCAHTOA always help in terms of when you're trying to identify whether the variables are in sin, cos, or tan? Does it always help?
I would agree. I would say write it down because it's less to keep in your head, right? So when you write it down, what I used to do is I used to do this at the beginning of all my exams, and sometimes I would even write, well, you don't have to do this, but sometimes I even write the Y, the R, the X above as well. But definitely write down SOHCAHTOA. It just takes some of the load off your brain. Yeah.
Okay, thank you, sir.
Cool. Okay, so let's see what we get for the cos of beta. I don't want the 5, but I do want the A, so it's going to be 12 over 13. So the cos of beta is 12 over 13 because this is the O, this is the A, and this is the H. I like what I'm seeing, and so I'm going to move on. I like what I'm seeing, so let's move on. All right, next type of question. I want to ask question number 1. Okay, I want to look at this type of question, and we're just going to focus on question number 1, and I'm going to make a statement. I'm going to say if sine is negative and cos is positive, then which statement is true, or what quadrant are we in? Is it going to be A, B, C, or D? So the cast diagram, where is sine negative? Sine is negative here and here. And cos is positive here and here. So which quadrant has 2 ticks? It's going to be this one over here, which is D. 270 to 360. Okay, so this is what we call locating the right quadrant. Let's try the second one. So D is the correct answer. Well done, everyone. D is the correct answer. Let's try the second question. So can you do this one? If tan is negative and cos is negative, then which of the 4 options is going to be correct? Just want to make sure you know where your quadrants are here. If tan is negative and cos is negative, then which statement is true? I always like to use the ticking method, so it helps me keep track. So tan is negative here and here. Cos is negative here and here, which means I must be in this quadrant over here because it's got 2 ticks, which means the correct answer is B. Nicely done, Nobusetu. Nicely done, Tato. That was very good. Okay, so let's move on. Will the following trig ratios be positive or negative? Tell me about the sine of 315. I want to know, is it going to be positive or negative? How would I know this? So the sine of 315, if you visualize that angle, it's going to be all the way around to here. And in this quadrant, sine is negative. And you can see that because the only thing that's positive in this quadrant is cos. Okay, now I want to use an idea from earlier in the lesson. I want to know, what is the sine of 315 reduced to an acute angle? So I want you to take the sine of 315 and I want you to try and give me an answer. And I'd love for somebody who's feeling brave to explain to me, how do I reduce the sine of 315?
We have a hand from Teddy.
Yeah, let's go to you, Teddy. Hi, Teddy. How would you do this one? What's the first step you ask
Hi,
yourself?
sir, can you hear me?
Loud
sir
and
hear
clear.
me?
Perfectly. Sounding great.
Okay, sir. First of all, you look at the nearest x-axis.
Yeah.
So that's 360 from 315. So that's
Yeah.
360. And then you say 360 minus
Yeah.
315, and then
Perfect.
it will give you sine 45, sir.
Okay, now you almost correct. You're perfectly correct about the 45. But there's something about the sine of 315 and what quadrant it's in. So when we start reducing, we always say, is sine positive or negative in this quadrant? And what is sine in this quadrant? Isn't it going to be?
Sir.
Yeah. So you get negative
Sine
sine
45. Okay, sir.
Okay. Fantastic. Okay, so watch out for that, because you will see that the quadrant that it's in, because it's in a negative, whenever you use the reduction formula, you have to use it to get the sine, and then you reduce it off the horizontal. Let's do the second one. Same sort of idea. I want to know, first of all, is the cos of minus 215 positive or negative? And then I want to use the reduction formula on that. So first tell me, is the cos of minus 215 positive or negative? And then I want to know how we would reduce it using the reduction formula to make it a smaller angle. Well done, Teddy. How would you visualize minus 215? What would you do to, is it going to be positive? Is it going to be negative? So Tapi has asked, how do we get the negative sign? Tapi, what we do is we ask ourselves, what quadrant is 315 in? And so using what's called the cast diagram, this thing tells us in quadrant 4, only cos is positive. So because we had sine of 315, sine is in, this is in quadrant 4, and so it must end up being negative. If it was in quadrant 2, if the angle ended up in quadrant 2, it would be positive. Okay, I'll show you again how this works in the next one. So let's take minus 215. We go the opposite way around. So here's minus 90, minus 180, and then minus 215 is going to be over here. Now, in this quadrant, you'll notice that it's in the sine positive quadrant, and because we're dealing with cos, it ends up being negative. Okay, now I want to know the reduction formula. What is, so we know that this is going to be negative because it's in quadrant 2. What's the final reduction formula going to be? What is cos of minus 215 going to reduce to? Let me draw this in again, because I think I've lost some of you. So minus 215, minus 90, minus 180, and then minus 215 would get you about here. Now, the nearest horizontal is minus 180. And so how big is this going to be? How big is this angle over here going to be if I have to get up to 215 or minus 215? I think that this angle has to be 35 degrees, because minus 180 and then Another 35 will get me to 215. Okay, so I'm using the horizontal. Whenever I use the horizontal, I have to keep my trig ratio the same. So this stays cos. And then we say it's 35 degrees away from the horizontal, so it's minus cos 35. It doesn't change its trig ratio because it's using the horizontal. Whenever we use the nearest horizontal axis, the type of trig ratio has to stay the same. I wonder if there are any questions about that. I feel like I might have lost some of you. So I'm going to give a moment for questions, and then we'll go on to do another one. Are there any questions? Okay. If there are no questions, let's try one more before the break. Let's try the tan of 215. Okay, Micah said, can I explain this step by step? Let me do C for you. Let me take you through this process for C. So let's do that. So how would I visualize, let's get rid of this thing over here. Yeah. How would I visualize the tan of 215 degrees if I went to my cast diagram? So here's my cast diagram. I go 90, 180, and then 215 is going to be in this quadrant. Now, in this quadrant, if I put in the summary, tan is positive in this quadrant. And since I'm dealing with the tan of 215, when I simplify it, it's going to end up being positive. However, it hasn't been reduced yet. In order to reduce it, I have to go to the nearest horizontal. The nearest horizontal is 180. And so, or another way of saying it is take 215. So 215 is the whole angle, and subtract the nearest horizontal. So if I do that, I'm going to get 215 minus 180. And then the trig ratio is just going to be tan because it's off the horizontal. So the final answer would be the tan of 35, positive the tan of 35. Does that make sense? Just get, I want to get a quick vote. So thumbs up if you're following my reduction formula, thumbs down if you're not liking the reduction formula. Quick little vote from the class. I want to see thumbs up, thumbs down. Both are very helpful to me as a teacher. Okay. Let's do one more. I want to know, and I want everyone to see in the chat, if I ask you the cos of 390, is that positive or negative? And what will the cos of 390 be reduced to? If I have to ask you to reduce it to an equivalent but acute angle. So first of all, positive or negative, and then what's it going to end up being? So how would I visualize 390? It's going to go the whole way around. And then it's going to go a little further. So it's in quadrant 1, everything is positive. Yep. And since it's off the nearest horizontal, which is 360, this is going to be cos, and then I'm going to just say 390 minus 360, so positive cos 30. Yeah, that's it. That's it. Now, you guys are doing fantastically well at using the reduction formula. But what if I said to you, and we're about to have a break, what if I said to you, you need to evaluate what the cos of 30 is without using your calculator? What would that be, and what tool would you need? Mike, how is it positive cos 30? The reason it's positive is it's in quadrant number 1. So it goes the whole way around. So 360, and then another 30 degrees to get to 390. And so it ends up in quadrant 1. Okay, I just want to do this last one. Cos of 30, how would I evaluate that without a calculator? I'll give you a little hint.
Mr. S,
Yeah.
can you go from Tandolo to
Oh, is there a question from, okay, Tando, where to? Let's go to you.
Sir, I wanted to ask about question D. From question D, can we conclude that the cos of 30 degrees is a obtuse angle?
So the cos of 30 degrees is not an obtuse angle, but it's an acute angle because it's less than 90.
Oh, okay. I thought because it's way above 360 degrees, it might be obtuse.
Oh, no, no. So obtuse would be between 90 and 180. But you're right. It's greater than 360 basically, and we reduce it to less than 90, which we call acute.
Okay, thank you, sir.
Perfect. Okay, Londeka, it's special angles. Perfect. Nolwazi, the same thing. What is the cos of 30 going to be in terms of a value? Well, if that's O, that's A, and that's H, what does the cos of 30 have to be using my special triangle? For cos, I need A over H. So what am I going to end up with? I'm going to have that one involved. And that one. And so I should end up with root 3 over 2. Just put that in your calculator quickly just to check that. So put cos 30 in your calculator and see that you get root 3 over 2. And if you do, give me a thumbs up. Awesome. Yes, we are winning. We are winning. Okay. People of grade 11, it is time to give our brains a break. I've pushed you very hard. And so I want you to turn on your cameras. I want you to stand up and I want you to stretch with me because we all deserve a break. Lebo, if you could encourage our family to just get up and do what's good for them and stretch. And there we go.
guys, please join us in the stretch. Give your
Guys,
mind
don't
a
let me have all the fun.
break. You've been working so hard.
Oh, come on, Bambi. You can do it.
Oh,
Is it
come on, Bambi.
missing out? You think you're winning at life because you're sitting down, but you're not. You have to stand up.
Not really. Yeah.
Stretch it out. Stretch it out.
Shout out to Katleho, Kuto, Nolwazi, William.
There we go. Oh, it feels so good to
Come on,
stretch.
guys. We love seeing your faces.
Look at those happy faces. Oh. All right. I'm loving it.
Come on, Bella.
All right. There we go. We are in this together. You know, like we talk about running buddies, these are your maths buddies. You gotta show your maths buddies some love. Like you gotta be like, I'm with you guys. I'm going with you on this journey. Okay. Let's have a quick look at a brain break. So I want to know what a kitten plus a lion plus a chicken gives you. It's over to you guys. What is, I want the final answer. Anybody who is feeling like they know the answer, let me know. What are we going to get? Nolwazi, I absolutely agree with you. There can be no doubt a kitten is worth 20. Now, if a kitten is worth 20, what is a lion worth? Careful, guys, because 2 lions have to be a lot more than 44. In fact, I was thinking, what would we normally do with an equation? An equation would say add 20 to both sides. Okay, Lee's, oh, people are throwing in their answers. I was thinking, get your answer in if you've got it. I was thinking 2 lions, I'll just say 2 lions is the same as 64. And if 2 lions is the same as 64, 1 lion must be 32. And then that means so that's, okay, so everyone agrees with the lion on being 32. Now what's the chicken going to be? The chicken is going to be 30. Come on. So what is the final answer? I think I saw it earlier on. Who managed to get that? Tulisiwe, Lee, I think you were on the money. Same with Nawazi, Karabo. The final answer is going to be 82. Fantastic, people of the world. It is.
Nice one, guys.
We are doing it. We're doing it. Okay, now I know you guys are craving some more trigs, so let's get back to that. And let's talk about a question like this, which is slightly harder, but basic idea. This is sort of an exam type question. So it says here that if the tan of theta is minus √3 and theta is between 180 and 360, determine using a diagram the value of the sine of theta. Now, I will give you a little hint here. The little hint I'm going to give you is that you need to figure out what quadrant you're in to draw the diagram. And what's more, when we have the tan of theta equals minus √3, the tan of theta equals minus √3 over 1 is exactly the same thing. So I want to ask you, what quadrant is my diagram going to be drawn in? Using what you've learned so far in the lesson, if I was going to draw whenever I have to evaluate a trig expression, I need a triangle. So I'm going to draw a triangle in a quadrant, and I want to know which quadrant should I be in. So we know that tan is negative and it's between 180 and 360. So 180 and 360 is here, but tan is only negative here. So you're right. The triangle that you're going to draw is going to be over here. Fourth quadrant. Fantastic. Okay, now I want to know, using this bit of information, I want to know from someone, how do I use this bit of information to help me find out what the sine of theta is? I want to know, how do I connect my drawing to the tan of theta is minus √3 and then somehow getting the sine of theta? Would anybody like to give me some help or some assistance on that? I was thinking that tan is O over A, or another way of saying is it's Y over X. So if you go, don't I need to think about, okay, well, look at this drawing. The X part is going to be positive. It's going to be 1. The Y part is negative, so it's going to be negative √3. So give me a thumbs up if you see how I've connected the minus √3 and 1 to my drawing. If you see how I've done that. Okay, now I want to know, what is the missing side going to be? What's the missing side going to be? How am I going to figure that out? Pythagoras, loving it, loving it. So using Pythagoras, we could say that basically we'll call that R or H, doesn't really matter, but we're going to go 1 squared plus minus √3 squared square rooted and I'll call that r, and it's going to be Pythag. And what do we get for the answer for that? It's going to be, so r squared is 4, but r is going to be 2. And so what we do in this type of question is we first draw the triangle and then we work out the missing side. Now that we have, yes, yeah.
Sorry, Mr. S. I
Right.
just wanted to ask, Mulala is asking if you can please explain again how you assigned the signs.
Okay, if we go back to the tan as a trig ratio, tan's trig, when you say the tan of theta, it means O over A, like from SOHCAHTOA, or using the Cartesian plane definition, it's Y over X, as in the Y-axis and the X-axis. So because if you look at the drawing, I'm in quadrant 4, this one over here is the X, and so that's why this over here is 1. Whereas root 3, it's a negative, and that's because this is on the Y-axis and it's going in the negative direction. So I hope that helps a little bit. So last thing I want is, what is the sine of theta? How do I use my drawing to help me find out what the sine of theta is? The sine of theta is O over H or Y over R. Okay, so Mike is asking about why is it positive 2? Mike, what we call the radius or the radial arm will always be positive 2. A positive. It'll always be positive. The line that goes from the middle, so what we call the radius, is always going to be positive. This is always a positive distance. Okay. So what is my answer going to be for this thing over here? So we are going to get y is going to be minus root 3, and then r is going to be 2. And so the answer is going to be minus root 3 over 2. And again, notice how I'm taking the information from my triangle and I'm just using it to evaluate this, because in this case, it says using the diagram. In the question, it says you have to use the diagram. See if you can work out 3 cos theta for me. How would you evaluate what is the value of 3 cos theta now that as we get going here? And then I'll show you the answer in a second. Using the diagram, what is the value of 3 cos theta? So what does cos consist of? And then what does the drawing say about this? So cos is a over h, or it is x over r, but I also have the 3 in front. So 3 times 1, and then over 2. So we should get 3 over 2. So 3 times the cos of theta is 3 times x over r. The x was 1, the r was 2. And so 3 times a half is 3 over 2, or 1.5. That would be the answer. Okay, so what I'm going to do is I'm going to stop there for today. This is typically the first question in trigonometry, right? So in trigonometry exams, you almost always see this first question where they say, use the diagram, finish it off, and then evaluate. And then the second question is normally about simplifying expressions with the reduction formula. And we'll continue with that in the next lesson. So what I want now is if there are any final questions or things you're unsure of from today, now is a good time to raise your hand. Otherwise, Lebo, if you could put the link to the poll in the chat so that students have a chance to sort of vote on the pace of the session. Question, Thando Wetu, let's go to you.
Sir,
Yes.
since the coefficient of the ratio is 3, does that mean when we're looking for the ratio, the original ratio or the whichever requested ratio, do we always multiply that ratio by the coefficient of the given ratio before the theta?
Yeah, so basically that number in front is like, it's just multiplied. So whatever you got for the trig ratio, you just multiply it by 3. That's all it
Okay,
means.
thank you. Okay, thank you, sir.
Cool, pleasure. Any other, Teddy, let's go to you. What's your question?
So my question is that I've always asked myself this. Where is theta in that triangle, sir? Is it always gonna be like in the center of where the two lines meet? Like, is theta always gonna be there?
Okay, so there's 2 angles. So what we talk about, earlier in the lesson, we spoke about the original big angle, and then we have the reduced angle.
Yes, sir.
And so there's there's an equivalence between the two because trig functions repeat themselves. So in terms of this is what I'll say to you is whenever you are evaluating something in a question like this, and they say use the diagram, you first have to draw the triangle, okay? And then when you draw the triangle, you're gonna find, you'll normally be given 2 pieces of information. You figure out the third side. Once you've got those 3 pieces, to evaluate that trig expression, just use the drawing. Don't mix it up with reduction formula at this stage. Like, just look at the drawing and take that information for now. Okay. I kind of, if I go into any more detail right now, it's going to muddy the waters. And so I just want to say for this type of question, stick with this method. In the next lesson, I will talk about what I call like generating angles and reference angles when we do equations. Okay.
Mr. S, there's
Yeah.
also a question from Katlego.
Okay, cool. This is going to be our last one, and then we'll go from there. Yeah.
Mr. S, I just wanted to quickly ask that how often do we use the Pythagoras formula? How often does it help us
So it's going to come up in almost every exam because whenever you have a trig ratio and they give you 2 sides, you need to use Pythagoras to find the third side. So Pythagoras is going to come up a lot in terms of, like, you do need to know how to use it properly in trig. Yeah.
Okay. Thank you, sir.
Pleasure.